Hello, my name is Chris Kitchen, and this is my video portfolio. This first project is an educational interactive display that I designed to visualize the transfer and encoding of binary data from one computer to another. Instead of using a wire that transmits high and low voltages to represent the ones and zeros of binary information, this system represents ones with dyed water and zeros with clear mineral oil running through a transparent tube. On the other side, a photoresistor and LED detect the changes in brightness between the opaque dyed water and the translucent mineral oil, enabling the other computer to decode the message. Then the liquids are returned to a shared reservoir where they naturally separate and can be reused for further communication. By the final prototype, I was able to get the system reliably sending and receiving messages purely through this physical medium, and designed it to have continuous bidirectional communication between two computers sending text to each other. This next project is one of my biggest and the best example of my collaborative capability. We worked with the City of Cambridge and a local architecture firm to design a unique art installation that could double as a play structure for a local playground. My proposal was selected from 6 initial proposals, and I took on the role of project lead for a team of about 10 designers working through, give or take, 100 different prototypes, both physical and digital, as we narrowed down the strengths and weaknesses of all the different ideas and tried to hone in on one cohesive vision for this installation. We took inspiration from the industrial history of this site to imagine these large underground pipes gradually being exposed and eroded into these unique, different forms. By the end of that process, we landed on 6 different designs that me and another designer presented to the public, to the City of Cambridge, and to the architecture firm. The design on the bottom left, the lichen, ended up being the favorite of those final 6. And these are some photos of the installation on the park's opening day. You can see it work just fine as a play structure, and every time that I visit, it seems the kids really enjoy it. My most recent projects include a Arduino-based custom controller that detects the opening and closing of a camera's shutter and triggers up to 8 different strobes to fire multiple times in completely custom sequences and timings. This was done to create a stroboscopic effect, a unique way of capturing motion over time that uses flashes going off multiple times at regular intervals to capture the nuances in the timing and position of a given motion. You can see this effect in the photo of the swinging ball, where as it builds momentum, the space between each exposure is much shorter, since it's moving much slower. But at the bottom, where it has the most speed, the spacing is much larger, since it moves more distance between each exposure. You can also see the different experimentations that I had with this. Because I designed the controller to integrate multiple strobes in completely custom sequences, I was able to experiment with using colored gels to create effects that I personally have never seen used with this technique. I've also been working on designing my own custom 3D printable cameras. I've designed about 5 at this point, most notably a handheld large format camera, a purpose-built Polaroid headshot camera, and designing a new format of instant 3D photography, creating these stereo Polaroids. I've laid out about 30 of the different iterations that I've gone through in the process of designing these cameras. I started by determining what equipment and scenarios I was trying to design around, and individually designing the interface points for each piece of equipment. Once I figured out how to securely interface with each individual piece of equipment, I then started designing the camera body that would put all these disparate pieces of equipment into proper alignment and harmony so they could all work together to create a highly functional and highly precise final system. From there, I further refined the camera body designs, as well as moving on to other different camera prototypes. By the time I made it to my most recent camera, the purpose-built Polaroid headshot camera, I was able to design the whole thing in one day, have it print in a single piece with no supports, and am to this day still using that first prototype for multiple different projects. This handheld large format camera features a locking bayonet mount, a fully removable handle with secret film storage, built-in strap lugs, built-in tripod plate dovetails, and full modular functionality with each piece of equipment involved, and precise alignment of these completely unrelated pieces of equipment. The Polaroid headshot camera features the same bayonet mount, enabling a quick switching of lens from one system to the other, a built-in printed viewfinder that I clearly had to recalibrate, a tape measurer for focus since it only focuses at one distance, and even a phone mount for filming content when I take it to different events. This is an example of the stereo Polaroid format that I created that enables quick and easy 3D photography that is shareable with the people around you. I'm in the early stages of the fully custom camera that I'm designing for the format, but can showcase the fully original dual lens mechanically coupled shutter mechanism that I recently made. This is the 5th iteration where I realized that having the tension spring cross over its central axis creates a switching in tension midway through the shutter stroke that increased its reliability dramatically. And this is my fully original zone focusing system for the camera that uses 3 distinct positions to enable quick and easy focusing by pure muscle memory. Lastly, as part of my photography thesis at Parsons, I designed this custom interactive display table. The work I was showing required being printed at a 4-foot by 10-foot scale per photo, but I was only given 4 feet to display my work. So I designed a custom display table that would allow people to physically crank to scroll through a 30-foot long print within a 4-foot actual footprint. I designed it over the course of about a month, mainly fine-tuning the material, size, and positioning of the rollers inside the system. I built the table by hand over the course of about a week and designed it so that the cranks and legs were easily disassembled to enable a flat pack storage and easy transportation in the back of a minivan. Thank you so much for watching, and I really would love to work with you guys. I hope that I can hear from you soon. Thank you.